Good afternoon and welcome to our Expedition 24 Spacewalk briefing. Russian flight engineers Fyodor Yurchikhin and Mikhail Kornienko are going to be going outside the station at 10:45 p.m. on Monday night. And to tell you a little bit about what they'll be doing out there, we have the Expedition 24 Spacewalk Flight Director, Chris Edelin, and the International Space Station Deputy Program Manager, Kirk Scheinman. We'll let them start with some opening statements and then we'll take questions.
Okay, thank you, Brandy, and good afternoon, everybody. Russian EVA 25 is scheduled for this coming Monday, July 26, beginning at 10:45 p.m. Central Time. It's planned to be a 6-hour spacewalk, and during which time the crew will replace a docking camera on the Zvezda module, as well as route new data cables to support activation of the new Razvat research module. We can go to graphic 1 that shows the EV crew. EV1 is cosmonaut Fyodor Yurchikhin, making his 4th spacewalk, and EV2 will be Mikhail Kornienko, making his 1st spacewalk. And both will have blue stripes on their Orlan spacesuits. Now if we go to graphic 2, this shows a side view of the Russian segment of the space station with labels for the modules that we'll be talking about today. The spacewalk will originate from the Pirs docking compartment airlock, which is in the center portion of your screen. That will isolate the 22 Soyuz vehicle from the rest of the station due to the hatch configuration used with this airlock. So that will require Station Commander Alexander Skortskov and Flight Engineer Tracy Caldwell-Dyson to remain in the Poisk research module for the duration of the EVA so that they have assured access to their Soyuz. This is just a standard safety precaution that we take for all EVAs to assure that the crew has immediate access to their Soyuz vehicle if required. The remaining crew members, astronauts Doug Wheelock and Shannon Walker, will have free access to the entire U.S. segment, as well as the Zarya module and their Soyuz 23S vehicle, which is located at the docking port of the Razvat module. Now for more details on the overall EVA objectives, we can go to slide 3, please. First, the crew is going to replace a degraded video camera at the aft end of the Zvezda module and replace it with a new one that was recently delivered to the station. This camera supports dockings of the European Automated Transfer Vehicle, or ATV. The ATV is an unmanned spacecraft that brings supplies to the station, and the video camera is used to monitor the approach as it comes in and docks with on the aft end of the Zvezda module. So the video camera currently on orbit has numerous bad pixels resulting in degraded picture quality. So the new camera is expected to restore the system to its full functionality in time for the next ATV mission, which is ATV-2, is scheduled for December of this year. After a ground checkout of the new camera, the old camera will be jettisoned. It will not be brought back inside the station due to concerns that the insulation around the camera has degraded in the space environment and could result in fiberglass particles being shed inside the station, resulting in a breathing hazard for the crew. So at the end of the EVA, we will jettison the old ATV video camera. The other big objectives for the EVA are to outfit the new Razvat research module, which was delivered to the station by the Space Shuttle Atlantis back in May of this year. First, a cable bundle will be run from the Zvezda and Zarya modules to connect the Razvat to the Russian command and data handling computers. Then a second set of cables will be run from Razvat to Zarya to provide full functionality of the core's docking system to allow automated vehicle dockings of Progress and Soyuz spacecraft to the docking port at the bottom of the Razvat module. Now we're going to go over the EVA timeline in greater detail, and for this we'll have an animation. We can go ahead and roll the animation. The spacewalkers are going to emerge from the Pirs docking compartment airlock, which is shown there on your screen in the lower portion. They will bring with them 2 cable reels containing the command and data handling cables as well as the core's cables. They'll also bring the new ATV video camera with them. They will proceed aft along the Zvezda module towards the very back end of the station. When they get there, they'll translate along the ring handrails to the ATV camera work site, which is adjacent to the 38P Progress vehicle shown docked on the aft end of the module. So the blinking square that you see there is the ATV camera. They will use a ratchet wrench to remove the connector. They'll take out the old camera, put the new camera in exactly the same location, and mate up the electrical connectors. And then they'll take the old camera and they'll translate back along Zvezda to the airlock. Now, while they're doing this, ground controllers in Moscow will be performing system checks of the new camera to make sure that it's functional before we jettison the old camera. So when the crew gets back to the Piers docking compartment, they will tether the old camera to an EVA ladder, leaving it till the end of the EVA. They'll retrieve their cable bundle reels and proceed up to the ball portion of Zvezda or Paka-O, and they will begin mating 4 electrical connectors of the command and data handling set of cables. And this will be about an hour and 45 minutes into the EVA when they get to this point. So again, they make the connections, and then they will also secure the cables with wire ties along handrails. And then they will proceed to the top side of the Zarya module and make their way towards the front side of that module, towards the US segment, stringing along the command and data handling cables as they go. The other crew member will also bring the Coors cable reel with them, which will be used a little bit later in the EVA. So when they get to the front end of Zarya, they'll come down the ball or Ga'a portion of Zarya. They will set up their work site with their cable reel, and they will install ties for to hold the cables in place, and then mate the electrical connectors on the Razvet module, which you see towards the lower part of your screen. That's the new module. So that will complete the command and data handling portion of the cable routing. The crew will also close the cover on the Razvat docking camera and remove 3 bolts as a get-ahead for a future EVA task. Then the crew will come around to the port side of the station, and they will proceed to mate the Coors cable to connect the Coors passive antennas on Razvat to the station computers, again to support automated rendezvous and docking on the new docking port on Razvat. They'll make their way back along Zarya, bringing with them the 2 empty cable reels, and return to the airlock. And this portion of the EVA is expected to take about 3.5 hours total. So once they're back at the airlock, assuming that the checkout of the new camera is satisfactory, the old camera will be untethered. The crew will use the Strela crane foot restraint, secure themselves, and then they will jettison the old camera in a retrograde direction, opposite of the direction of travel of the station. And the expected release velocity is about 0.5 meters per second. And with that, the camera will phase out in front of the station. And since its drag deceleration is greater than the overall station, it will slowly lose altitude and continue phasing in front of station. And after about 120 days, it is expected to re-enter the Earth's atmosphere and burn up. So after jettison of the camera, the 2 spacewalkers will ingress the airlock and begin repressurization. Then they'll open hatches, doff their suits, and begin the post-EVA activities. And now just for a few general notes, one new capability that we're going to use for this EVA for the first time is the Orlan Spacesuit Telemetry Measurement Unit, or TMU. This will provide detailed suit telemetry to ground specialists in Mission Control Moscow by way of the US S-band communication system on the station. Currently, this type data is only available for short periods once every orbit, about 10 minutes, 10 or 15 minutes out of every 90 minutes. So this is a significant safety enhancement to provide greater visibility for ground controllers to monitor things such as suit pressure and oxygen remaining. One other note, this is a Russian-led activity. The spacewalk will be run by the Russian flight control team in Moscow. The U.S. team in Houston here will do several things to support the spacewalk. We're going to park our solar alpha rotary joints and our thermal radiator joints in order to allow us to hand over attitude control to the progress thrusters for the airlock depressurization. And after depress is complete, we will hand back attitude control to the U.S. side in order to use the non-propulsive control moment gyros so that we don't use propellant to maintain attitude during the EVA. We're also going to power up an additional string of our S-band radios on the station in order to provide redundant voice and telemetry for flight control. And we'll be tracking the crew using U.S. external video cameras mounted on the station truss. However, we expect to have pretty much limited views of the spacewalkers due to the fact that they're going to be on the back side of the station and our cameras are towards the front side. So limited views there, and also the crew will not have helmet cam. So for training, the crew has been trained on this EVA prior to flight in the Hydrolab facility at Star City in Russia. This week, they've been gathering the necessary tools and equipment for the EVA and reviewing procedures for the tasks that they're going to perform, as well as their suit procedures. And today, they're setting up and sizing the suits. Tomorrow, they will be performing a telemetry test of the new TMU. And then Friday, there will be a suited dry run to go through all the procedures all the way from depress the airlock through the EVA itself and then back to re-ingress. Suited dry run Friday. Saturday and Sunday are crew days off, and then Monday they'll be well rested, and they'll actually have a 12-hour sleep shift, waking up about 2 p.m. Central Time to begin the EVA prep operations. And that concludes the formal part of the brief.
Okay, we'll hear next from Kirk Shireman, Deputy Program Manager.
All right, thanks. Good afternoon. It's great to be here to talk to you about the International Space Station. Chris did an outstanding job telling you about the upcoming Russian EVA, so I'll tell you about a couple other things that are going on the ISS that have either occurred or are going to occur in the near future. First, we have the Russian EVA on the 26th going outside about 10:45 p.m. local, and we have the U.S. EVA coming up on August 8th, and we'll go outside about 6 a.m. local. So, and I know we'll have another briefing here, I believe, on August 3rd to talk to you more about the details there. So, as you know, there's lots of activities. It's not just the spacewalk itself, the hours that we're outside. There's actually a significant amount of preparation activity going on board on the Russian side and the U.S. side in preparation for these EVAs, and we'll talk to you more about that. On the ground, we have some significant activities going on as well. In Florida, we have the Permanent Multi-Purpose Module, or PMM, and that module is undergoing, it's actually being loaded as we speak. We're installing racks and cargo on the inside of that module, as well as installing improved micrometeorite and orbital debris shields on the outside, and that activity is going very well and on schedule to support the launch this fall. Also on that flight, we have an external logistics carrier, and that external logistics carrier is going to have a large radiator ORU. In fact, this radiator basically takes up one side of the ELC, and that's actually being installed this week. So it's a major activity for the preparation of that flight, which is ULF-5 STS-133. In addition, going on in Florida right now is we're also preparing the other external logistics carrier that we have that's going to fly up on ULF-6 or STS-134. We're preparing the spares that are going to fly on that module as well. The alpha magnetospectrometer, as you guys know, is undergoing its final reassembly and test over in Switzerland as we speak, and it'll be arriving later this summer in Florida. On board, the crew, in addition to preparing for these EVAs and doing some maintenance work, they're also performing research. We've been performing an experiment called SAME, or Smoke and Aerosol Monitoring Experiment, which is looking at the performance of small particles and aerosols to lead towards better, improved smoke detectors for space applications and also terrestrial applications. We've been doing some capillary flow experiments, which look at the capillary flow or flow of liquids in zero-G. This will help improve our theoretical understanding of capillary flow, which we believe will lead to more improved designs for tanks for space applications. Again, tanks to allow us to fly and restart engines in space, which will need to go beyond the low Earth orbit. And also, one of the neat experiments we've been doing, it's really an educational experiment, it's called Kids in Micro-G. We've been having the crew perform experiments that were actually designed by 5th through 8th grade students. These students came up with ideas of experiments that could be performed with classroom-type activities, classroom-type objects. And they perform the experiment, they design the experiment, perform it in their classroom, and then the crew is performing these experiments on orbit and filming it and sharing it with these kids. So that's a really neat activity to engage our children and encourage them to take careers in math and sciences. And the last thing I'll mention, of course, is we're looking forward to our commercial crew partners. The Dragon, SpaceX Dragon, is going to have its first demonstration flight later this summer, and we're looking forward to that. Now, that flight's not going to ISS, but it's an important precursor leading up to the first commercial resupply flight, which is going to be to ISS, which will be next year. So with that, I'll hand it back to Brandy.
Okay, and we'll start by taking some questions here in the room.
Gina Sinceri for ABC News, sorry. I know you don't lightly toss something overboard like this camera, so what went into the decision to jettison the camera, and what kind of orbital debris risk it would provide?
Well, there is a formal process to jettison objects. Basically, it comes down to a risk trade between bringing it back inside versus throwing it overboard. And in order to normally to jettison something, we have to show that bringing it back inside is either risky to the crew or it causes problems in terms of internal stowage on the station, or we can't figure out a way to get rid of it on a Progress vehicle as trash. So in this case, with the ATV camera, it does present a hazard to the crew due to the insulation surrounding the camera. The concern is that that insulation could flake loose inside the cabin, resulting in fibers that the crew could breathe in. So once that determination was made, then it was clear that jettisoning was the right thing to do. Then we proceeded to do ballistics analysis. Our trajectory operations team here in Houston analyzed the physical properties of the object in order to predict the relative motion, the orbital mechanics of the object as it's discarded from the station. We also assure that the crew is thoroughly trained in the proper techniques. You want to be very deliberate and careful and know which way you're tossing something overboard. So all that was part of the planning for the jettison of this object.
And if I could add a little bit to that, we do have an official ISS policy on jettison activities, and this, which is we look at it well beforehand and do the ballistics, and then and do this overall risk trade that Chris mentioned. And then the last piece of the risk that is not really an issue here, but in general we look at, is we actually, based on the materials properties, look at the risk to the population on the Earth. So if a particular object if we look to see if it would survive all the way to the surface of the Earth, and if so, what would be the risk of causing damage to people, or to property, or injury to people on the Earth.
How large is this camera? Can you give me the specs on it?
I don't have the specs with me now, but I can get that to you. It's it's approximately this size.
Okay.
Red box size, of course.
Thank you.
Mark Carreau for Aviation Week. I had a couple of questions. I wonder, in a big picture sense, this gives you 4 Russian docking ports. And I'm wondering how important that is to the space station going forward, especially when the shuttle won't be available. And will this port also take the ATV once it's fully outfitted?
So 4 docking ports are really important to us. Several years ago, we worked as a partnership and agreed that we needed to have 4 docking ports, in particular for this time frame, because we have to have 2 Soyuzes present, and in order to allow Progresses to come or an ATV to come, and have some redundancy, we really needed to have 4 docking ports. So it was really important from that perspective. Right now, the ATV really can only come to the aft end of the service module, and really that's our plan. The ATV carries a significant amount of propellant. Only a portion of it is transferable to the service module tanks and the FGB tanks. The remainder needs to be used for reboost. In order to use it for reboost to the entire stack, it needs to be on the aft end. So that's our plan, is for ATVs to continue to fly just to the aft end. And as you know, we have this camera that Chris is talking about. The only place with that camera is on the service module aft end.
Thank you very much. And I had another question that had to do with the last docking activity with the Progress. Did you ever nail down sort of what happened there and whether it was a kind of a one-time issue as opposed to something that would be a problem again?
Yeah, so far the investigation is not complete. We believe the Russians have done the preliminary investigation and shared the results that the abort was nominal. In other words, the spacecraft lost link, not complete link, but link with this telerobotic operated panel. They had turned it on, it came on, and then it lost link for a specified period of time. If it hasn't regained link in that period of time, it performs, actually it goes to free drift, which means it turns everything off and just basically glides past ISS, and that's exactly what happened. So that part of it performed nominally. The question is, why did it lose link? We've actually performed 2 tests subsequent to that on that system, the telerobotic operator system, and it's performed nominally. So we don't know the root cause of that, and that's still under investigation. And we expect to hear more from our partners as they learn more.
Hi, Robert Perlman with CollectSpace.com. First with a question about the spacewalk. Between the camera activity and the cabling, is there one that takes precedence over the other if they were to run into trouble with one activity or the other, that it has to be done on this spacewalk given activities down the pike?
Let's see, the Russians do have another spacewalk planned in November. Therefore, they will have another chance at doing the camera task if it comes to that, because ATV is not launching until December. So I presume they will not spend an inordinate amount of time on the camera task, that they will preserve enough time to do the cable routings if they run into trouble on the camera.
And with regards to the activities that have been going on this week with Dexter, can you just provide an update on where they are? I think I heard earlier today that there was that they had run into a little bit of trouble with it, and wanted to see what the plan forward was.
Sure. Dexter's, of course, a very, very complicated robot. It's using its many joints, but it's also using the SSRMS and a lot of software on board. And actually on the ground. Right now, our plan is to use Dexter completely via ground control, so the on-orbit crew really isn't involved in that operation. So since it's been on orbit, we've gone through a whole series of checkouts, and we were leading up to this week to actually perform a replacement. We have 2 basically power switch modules. We call them RPCMs, remote power control modules, but basically banks of switches that power various components. And they each have a failed switch in these modules. We were just going to swap them, because if you swap them, the failed switch goes to nothing if you get them lined up right. So this would actually be the first official repair that will have been performed by Dexter, the SPDM. Leading up to that, yesterday and today we had planned some final activities. One of them was to grab one of the RPCMs and actually pull it out and then put it right back in. In performing that activity, when we started to pull it out, we were building up excessive forces, and it doesn't mean that we're damaging anything. It actually has force sensors in there, and we knew what we should expect in terms of force measurements, and they were higher than we expected. And so we stood down, we stopped and reinstalled it and left it at that. So right now the team is going back and spending some time to understand exactly why that is. There are a number of reasons why that might be. It might be something as simple as we were off a little bit on our turn counts of the bolt, so we still had a thread or so engaged on the bolt. Could be that it was slightly misaligned. It fits down in a channel, and so if you're not exactly aligned when you pull something out, it has forces. When you do it with your hands, it's real easy. You just nominally readjust and pull out, but a robot doesn't do that. It's a little more complicated. So all these things are learning experiences. We did expect to learn some things in this process, and so there's nothing major that we believe is wrong at this point in time. Because we have some other activities going on, of course, preparation for the Russian EVA, and we've also been spending a lot of time working on our oxygen generation system on the U.S. side. We've chosen to stand down for a few days. As we speak here, there's a team of engineers over in the Mission Control Center team talking through what we think might be the issues and how we might go back and nail that down. And we'll decide whether it'll be later this week or sometime later beyond that when it makes most sense to go and reinitiate that activity. But again, this is all really a learning activity, and this is our future. We expect we'll get past this, and in the future, that's how we'll do a lot of maintenance activities outside, is with Dexter.
Thank you.
Okay, I believe that was the last of our questions, and we don't have any more questions at other NASA centers. Sorry, we have one more follow-up.
Gina Sincere, ABC News for Kirk. Given if another shuttle flight is landing, what would be is going to take off? If they do add another shuttle flight, okay, what would your dream be to stuff on that flight to take up to the space station? I mean, you welcome any opportunity to bring other supplies up, I take it.
Sure, we're looking at what cargo today. We're looking at what cargo we would fly on that flight, and so it really depends on what's happening with ATV, what's happening with HTV, and what's happening with SpaceX and Orbital, and when those vehicles, the ones later on in 2011 and 2012, are going to show up, and that'll really drive what cargo we'd put on there. For instance, we'd do an assessment if we think those flights are going to slip. We would look to make sure that, number one, that we're keeping the crew healthy, so we have sufficient supplies of water and basic human needs, those kinds of things. We're looking to launch significant amount of payloads, so both up and down. One of the beauties of having an extra flight is we will have a significant down mass to bring home cargo, not only cargo of items that are broken that we can repair, but also payloads, samples, and so forth that we'll be able to bring down at that time frame instead of waiting for the first Dragon return. Those are the kinds of things. And then finally, any spares, and additional spares that we have to launch. We're still manufacturing spares to take us through 2015 and beyond. And so we'll have some additional ones that will have come off the assembly line that we would look to launch. So it's hard to say exactly what specific equipment we'd launch, but our philosophy, again, would be looking at when we think those other resupply flights will be, and then making sure that we meet our priorities. Number one, keep the crew healthy. Number two, make sure we have great research to go do, both up and bringing samples down, and then three, spares to keep ISS up there for the long term.
Mark Carreau for Aviation Week. Could you kind of review where the Soyuz spacecraft are? I know one is at Rosvat, or the MRM. I'm not sure where the other one is docked right now.
Let's see. Today we have one on MRM-1, and the other is on MRM-2. So Rosvet and Piosk, yes. I'm still trying to remember those names. And in fact, earlier there's a question about which is more important. The next one to go to Rosvet is actually in December as well. So we expect both those activities, having the camera and those cables, are important because both those the next use of both the service module aft and the MRM nadir is in December.
Okay, I think that was the last of the questions, so we'll wrap up today's briefing. Again, Monday's spacewalk is set to begin at 10:45 p.m. Central Time. That's when flight engineers Fyodor Yurchikhin and Mikhail Kornienko will be heading out the door. Coverage of the spacewalk will begin at 10 p.m. Central as they begin to get ready for the spacewalk. And then we'll also be back here on August 3rd for a briefing to tell you about the next spacewalk by U.S. flight engineers Tracy Caldwell-Dyson and Doug Wheelock. That briefing again will be on August 3rd, and the spacewalk itself will take place on August 5th. In the meantime, you can tune back in at 10 a.m. Central Time tomorrow for the daily ISS update, and always, as usual, keep track of all activities on nasa.gov. Thanks so much.